Welcome back to R for Economics. In this video, we'll be talking about the ARIMA models. So first, we need to install the package forecast. They get a pop-up to restart the session. And it is now installed. We can turn on the library. This has a World Wide Web usage, which we can see here, which is an installed database, but you'd be using your own data. We can run an auto ARIMA model. And here we go, we got ARIMA 111 that it came back with. And we can see the coefficients for the MA and the AR components. If we wanted to get the AIC of this model and BIC, we can extract those using the AIC and BIC functions. Now, if we want to forecast one period ahead, we can do that just using the forecast function, which is also in the forecast package, where we say H is equal to 1, and it'll give me 1 point ahead. But what if I wanted 10 points ahead? Well, there we go. We just have to change H is equal to 100 is equal to 10. We could change that to 100 or whatever we want. Now, let's say I didn't want to use the auto ARIMA function, and I wanted to use an order that I define myself, a PDQ that I define myself. Well, first I can use the one that was generated from the auto ARIMA, and we can see that I get identical coefficients back again. If I wanted to change it, let's say I wanted D to be 0, and now I get an AR model, and now I have a mean as well. Okay, so changing that back, or if we wanted to change this to 2, it's now an AR2 in this one. And you can see that this second one is not significant. Now, we can also grab the AR order from the actual estimation. So it's saying PDQ is 111, and we can use that to fit a model. And we get exactly what we got originally. Now, one thing about a time series is that we may want to do a forecast and look at these and how well our forecast does. So we can make a time series of, let's say, cut it off at 60. So we take 60 observations. Well, this is numeric, it's not a time series, so it's not going to work in our auto ARIMA. So we just need to use the TS function. And now it's a time series that we can use. And we can plot the first 60 observations. Now, if we fit the model, we can see that we got a PDQ 111. And our summary, these coefficients are very similar to what we had above. So it looks like the forecast is fairly stable, or the model is fairly stable between these two. So let's just generate a time series of our the 40 observations we dropped off. And we can get the forecast, our forecast, and we can grab the mean, which is our predictions of these. So that's the predictions. And then we can find out the difference. And find out how well we did. Well, we did great for the first 20 or so observations, and then we did terribly as the data jumped in that last little bit. And we saw that, so we did not capture this large increase that occurred here. So we were able to do 60 through 80, but this large increase for the last 20 we didn't capture. Great, we'll see you in the next video.